So welcome to another video by Adrian Davey from Pure Electric. In this video I'm going to show you what happens if you incorrectly connect a ring when doing your R1, R2 testing. Okay, so first thing we need to do before we do this, we check that we've got continuity on our ring final conductors. So I set my test meter to low ohm resistance. I check the leads are nulled, which they are. The gate is closed, gate's open, my testers are working correctly. Just going to untangle my leads. Okay, so first thing we do then, we test end to end, and I've already put resistances in, as you can see from the video before. Same resistances on the line conductor. Between each leg is a 1 ohm resistor. So 1, 2, 3, 4, 5, 6, 7 ohms. I've recorded it down here and I've recorded it up here. So if I test between there, I would have got 7 ohms on my machine. With the CPC, because it's smaller, and to represent that, I've given it a 2 ohm resistance. I know it's not 1.67 times smaller, but it is easier to work out with an exact measurement of 2 ohms. So again, each leg is now a 2 ohm resistor. I measure those, 2, 4, 6, 8, 10, 12, 14 ohms of resistance end to end. I've got continuity. I can now proceed with the R1, R2 testing. For the purpose of this, I'm also going to check the RN, which would be exactly the same resistance as the R1, and I would have recorded that down there. I haven't put it in because I want to try and keep this as simple to follow as possible. Okay? Before anyone comments on that. So up here we've got the 7 ohms, R2 14 ohms, add those together, 21 ohms. 21 ohms divided by 4, which we saw in the video before. We've got 4 separate resistances, which I'll come on into a minute. And we should be getting 5.25 if we had it connected correctly, which we don't. So I'm going to show you what happens when you don't have it connected correctly. If you remember from the video before, this is incorrectly connected. Okay, when it was correctly connected, this CPC connected into this line, and this CPC connected into this line conductor, and then we had that figure of 8 configuration. Okay, so this is incorrectly done. In fact, I'm going to write it up here so people can appreciate this is incorrectly connected. So incorrectly connected R1 plus R2. So for those of you that are watching, just to confirm that this is an incorrectly ring that I'm going to be setting up. Okay, so in this instance, what I'm going to do into my connector blocks, I'm going to connect the live from leg 2 into the CPC of leg 2, same as what we've got up here, and then the line from leg 1 into the CPC of leg 1. Now, for those of you that haven't watched the video before, to understand what's actually happening here, you have to understand how this meter works. So this meter, obviously powered by batteries, has a voltage. We know what the voltage is because it measures the voltage. It then uses the current from the batteries to push electrons around the circuit, and when we have electron flow, we can then measure that, and we can get, using Ohm's law, we can get voltage divided by current. It gives us resistance. Okay, now if you've connected this ring up incorrectly, okay, so your R1, R2 aren't in a figure of 8, they're actually like this. Okay, what's going to happen is, and I'll show it up here first, and then I'll show it down here second. Okay, I'll start from this end. If I test, so I'll make sure this is on, make sure it's nulled and it's working, so circuit open, circuit closed. When I test up here, electrons will take the path of least resistance. Okay, So this small loop here is going to get the greatest concentration of electrons because they can flow easily through this small resistor. Not so much through this large resistance. There will be some electron flow, but not as much as there will be here. So when I measure at this point here, I'm expecting a low resistance reading because the electrons can flow easily. When I get to the middle point, so this is equidistant, okay? At this point when I test, because this resistance and this resistance are the same, I'm going to get a balance of electron flow, okay? So the electrons are going to be flowing equally through that part of the circuit. That will give me my highest reading, okay? So lowest, highest. What do you think is going to happen when I come to this side of the circuit? Well, it's going to be exactly the same as what's happened there, okay? I test between line and R1, so R1, and R2 here. I've got a small resistance here, so most of the electrons are going to flow through this part of the circuit, back into my machine. So down here, through there, back up here, through the machine's going to measure that electron flow. So I've got the most electrons flowing here. Not so much now through the longest part of the circuit. So I'm going to get another low resistance. So let me just write this in so you can understand. We're going to have low, we're going to have highest in the center of the circuit, and lowest, and low back down towards the connection at the other end. That is exactly what I've got here, okay? And now I'm going to show you what the problem is, all right? Because when I come to test at every single socket, I'm going to get a different resistance, not like in the previous video where we connected into the configure of 8 configuration. I got the same resistance at each socket, so I could see which sockets were on the ring because they were all the same reading, and if I had a spur, it would be higher, okay? Here, we're going to get all different values, okay? Admittedly, they will be pretty equal as they go around the circuit at different points. So this socket and this socket closest to the connection will both be my joint lowest. This one and this one will be my medium readings, and these two in the middle will be the highest, okay? When you come to test at a house, you won't be able to see which way the cables are going, so you will have no idea. It's easy to see when it's drawn out on a board. And also as well, in this circuit that I've drawn, the sockets are all balanced out equally, okay? Almost symmetrical. When you come to someone's house, there's never a socket in the middle of the ring, okay, ever. Well, unless you set it up that way, but it would be very difficult to measure it out exactly, and all of these will have different resistances in. For the purpose of the video, I've made them all the same resistance so we can see what's going on, okay? But in reality, these will all be different. Okay, let's get on. So I'll test this side first and we'll work our way around the board. Same as the video before, what I do is I set this to continuity, check that my leads are nulled, closed circuit, open circuit, fantastic, I know my meter's working. I test between here and here. At this point, the electrons are flowing through this part of the circuit. So I've got a 1 ohm resistor on the line. And then back to my test point here. So I've only got a 1 ohm resistor on the CPC. At this point through the circuit, okay, the longest loop, I've got a 1, 2, 3, 4, 5, 6 ohm resistor on the line. And then coming back from this connection, I've got a 2, 4, 6, 8, 10, 12 ohm resistor. Okay, so we're getting very different readings from what we got before. Okay, so let's add that up. So 1 plus 1 is 2, 12 plus 6, 18. Okay, instantly we haven't got 21 ohms, which is what we should have calculated. Okay, we've only got 20 ohms. If I divide that by 4, we've only got 5 ohms of resistance. We can't divide it by 4 because it's not equal. So what we then do, if I do it with the reciprocal method, Okay, so 2 to the reciprocal of 1. Oh, hang on, what's happened here? So 2 to the reciprocal of 1 plus 18 to the reciprocal of 1 equals the reciprocal of 1. I have got a reading of 1.8. Okay, so at this socket here, so that is 1.8 ohms. Okay, so down here, in fact, if I do it in red, it'll help it stand out a bit. So here and here, 1.8 ohms between there and there. In fact, I don't know if that complicates the issue. Hang on, I'll tell you what I'll do. So this is my meter. Okay, I'm using red and green cables, so I'll make it easy for you. Between here and here, I'll be getting 1.8 ohms. I'll do it in red. 1.8 ohms. Now the reason that I'm getting 1.8 ohms is because I'm only picking up this part of the circuit. Some of the electron flow is going that way, but most of it's coming this way. As we work our way through the circuit, I'll keep showing you. So let's take these figures out. So these will change. So at this part of the circuit, if I test between here and here, this way I've got 1 ohms, 2 ohms before I come back on the CPC. So I've got 2 ohms here. I come back on the CPC and I've got 2 ohms, 4 ohms. Okay, so that's 4. From this point I've got 1, 2, 3, 4, 5 ohms. And I come back on the CPC, I've got 2, 4, 6, 8, 10 ohms. Okay, add those up. So we've got 6 and we've got 15. Okay, we do the reciprocal of those. So 6 to the reciprocal 1 plus 15 to the reciprocal 1 equals reciprocal the answer. And I've got 4.285, so 4.28. And that's 2 reoccurring. Yeah, 4.28. 4.28 ohms. So again, if I was to draw my meter in at this point, I'll use red and green to represent these cables here. So we've got that and that. At this point, I'm going to get 4.28 ohms, give or take 0.05 for tolerance. Okay. As you can see already, we're getting very different figures as we work our way through the circuit. Okay. Now, if this was in a real situation on site, you wouldn't be able to see where the cables are. You would have no clue where these sockets are on the ring. Okay, you're getting all different values. You wouldn't know whether it was a spur, whether it was a spur off a spur or a spur off a spur, you know, and forevermore. Okay, so that is why we don't test R1, R2 in this configuration. I'll keep going though, just so you guys can, you know, sort of keep seeing what's happening. So at this point, I would test here. Most of the electron flow is still going this way. So you've got 1 ohms, 2 ohms, 3 ohms. I can change that for 3. Comes back on the CPC, so 2, 4, 6 ohms. And then from this point it would be 1 ohms, 2 ohms, 3 ohms, 4 ohms on R1. And then coming back we would have 2 ohms, 4 ohms, 6 ohms, 8 ohms. Now at this point we're almost in the middle of the circuit. Okay, so let's add those up. So 9 ohms and 12 ohms. At this point, I'm going to almost get what I should be getting, 21 ohms. Or half of that actually, so it should be about 10.25. Okay. So 9 to a cyclical of 1 plus 12 to a reciprocal of 1 equals, on reciprocal the answer, and I've got 5.14. Okay, let's do that here. So 5.14 ohms. Now that is close to what we're supposed to have here. Okay, but that's because we're at the center point. Just change these figures here into red so they all match. I forgot what that was now. 4.2 so 2 also be 6 to reciprocal 1 plus, and that would have been 10, and no, that's not right. Oh, let's add it up again. So 1, 2, 2, and that would be 2, 4, 6, 6 to reciprocal 1, plus, and then we would have 1, 2, 3, 4, 5, 2, 4, 6, 8, 10. So that's it, 15. Reciprocal 1 equals. Oh, why is it doing this? 4.28. Right. We got there in the end. Right. Okay. At this point, my meter would have been connected in. Using the same colour leads as what I've got connected here. So into that, and that would have given me 5.14. Now, it's worth noting that at this point, halfway through the circuit, okay, I would have been getting what I would have here. So 7 ohms plus 14 ohms would equal 21 ohms because I've got an equal balanced ring. 21 ohms divided by 4, 5.25 ohms. Okay, I'm slightly off of centre, so I'm happy with that. It kind of balances out. So that's why I've got that figure up there. Now, because these are equal, as I come back round this side, they're going to be the same. They're going to be the same amounts. Okay, so my meter. In fact, I won't draw the meter ring because it's just going to confuse the issue. Here I would have 5.14. Here I would have 4.28. And here I would have 1.8. Okay. if you're thinking that you could go onto site and then be able to predict what's going on there, you wouldn't, because as soon as you can't see those cables, this might not be running a circle. It could be zigzagging all over the place and it won't make any sense whatsoever. So that is why we do not test R1, R2 incorrectly like this, okay? Because these readings don't mean anything. They're all over the place. Current is going to flow down the shortest part of the circuit, so you'll get a low reading. In the center point, you'll get equal electron flow, so you'll get the highest reading. And then as you go back around the circuit, it will start to take the shortest path again and you'll get the lowest reading, okay? You won't be able to tell if there's any circuits that are spurred off or radials or anything. None of the results will mean anything. So hopefully, if you've seen the video before this on a correctly connected ring, okay, then that will all make sense. I hope this video has been of some use to you. Again, if there's something that I've said that isn't quite right or doesn't make any sense, question me on it. We'll talk it through. We'll all learn as a result. The world becomes a better place. Take care.